Practice set 19, problem 6. Determine the indicated distance D. What we have is a pin sitting in a groove, and they're asking us what is the distance from the vertex of the groove to a point at the top of the pin. Well, from the center of the pin to a point on the circle or center of the circle, we have a radius. They're giving us the diameter is 10. So a radius will be half that distance of the diameter, in other words, 5 millimeters. So part of our distance that we're looking for is here, a point on the circle or cross-section of this pin to the center describes a radius and has a length of 5. We now need to find the distance between the center of the circle to the vertex of the groove in the pin. Let's start with drawing another radius though, and this radius is from the center to the point of tangency, which is actually the common point between the circle and the side of this groove. When you have the radius drawn to the point of tangency, a right angle is formed. If we draw another line from the center of the circle to the vertex of the groove, this line will bisect that angle, and we've just formed a right triangle. Our goal will be to find the distance from the center to this vertex, and let me draw that right triangle a little bit larger so we can fill in this information and solve for our missing side. This is the center of our circle to the point of tangency. That's a radius, so it has a length of 5. The angle of our groove was bisected when we drew the line from the vertex to the center of the circle. So half of the given 34-degree angle measurement of the groove gives us an angle of 17 degrees in our triangle. We're trying to determine this length. Next, we're going to label the sides of the triangle so we can decide which of the trig formulas to use to solve for our unknown. Since we know this acute angle, we'll use that as our reference angle. Next, we'll label the hypotenuse, the longest side, the side opposite the right angle. Through the triangle, the opposite side has a value of 5, and our third side is the adjacent. Since we're looking for the hypotenuse and we know the opposite, we'll use the sine function. Sine of an acute angle is found by taking opposite over the hypotenuse. Plugging in the values we know, sine of 17 degrees is equal to opposite, which is 5, over the hypotenuse, x we're trying to determine. To solve this equation for x, we'll eliminate the fraction by multiplying by the value in the fraction. In other words, x. To maintain equality, both sides need to be multiplied by x. We'll leave the left-hand side temporarily. The right-hand side will simplify this fraction multiplication, and when you have a common factor in the numerator and in the denominator, they cancel out, giving us a value of 1. 5 times 1 divided by 1, the right-hand side is equal to 5. To get x by itself and to undo the multiplication, we'll divide. We'll divide both sides by the sine of 17 degrees. Again, anytime we have a common factor in the numerator and the denominator, they cancel out, giving us a value of 1. X times 1 leaves x. And on the right-hand side, we'll do the indicated division. We're going to take 5 and divide it by the sine of 17, giving us a value of 17.1. We now have the value for the distance between the vertex of the groove to the center, 17.1, from the center to a point on the top of the pin will give us the entire span. So the distance is x, which we found to be 17.1. The center to a point on the circle, the cross-sectional area of the pin, is a radius. We found that to be 5. Adding those together gives us a value of 22.1 millimeters for the distance being sought out by this problem.